do this chapter 23 warm-up quickly. And so here we go. Mu, this is about the professor's class at a large university. And so I personally think it's unclear if we are generalizing to all the students at the university or just her students. So I'm going to go as if we are generalizing to the average credit hours for all of this professor's students. Okay, so I'm going to go with that. So the average credit hours, make sure you use the mu symbol and make sure you start with average credit hours for all of this professor's students. All right, that's the parameter. Now the hypotheses. The null hypothesis is that mu equals 15. It says that up there in the first sentence. The alternative, she is wondering if students are actually taking more. So mu is greater than 15. Remember, the null is always equal. The alternative is something else, so we've got that. Now we're going to do the assumptions. So here we go. For the assumptions, we're going to start with random. And so we are making the assumption that, well, actually it does state that these 24 students were taken randomly. For independent, we are saying that these 24 are less than 10% of all this professor's students. Okay, because that's the population to which I'm generalizing. Large enough is a problem because 24 is not large enough. 24 is not greater than 30, so it is not large enough. So now I look up top to see, does it say that the distribution or the population is approximately normally distributed? And it does not. So now I know I have to do a histogram. So I'm going to go ahead. I'm kind of running out of room here, but let's see if we can't do this fairly quickly. I've got a histogram here. I know that what I'm going to put down here is the number of credit hours. And then I know that I'm going to be having the number of students that have those credit hours as the side axes. So let me look at my data. It's going from 21 to 12. Okay, so it's spanning, what is that, 9, a distance of 9, and I know I should have about 5 bars. I just want to do this as easily as possible. I'm going to make these go up every 2. Okay, so I'm going to make these go up every 2, and I'm going to say start at 12. I'm going to start at 12 and go to 14, 16, 18, 20. All right, so here we go. All right, for the first one, 12. Luckily, these are put in order. So I'm going to go and put 12 and 13, go in the first bar. Okay, 14 and the 15s go in so there's going to be 2 in the first bar. The 14s and the 15s are in the second bar. There's going to be 5 of them in the second bar. Okay, so I'm going to have 2. I'm going to have 5. Okay, let's see how many I have from 16 to 18. Whoa, I've got 1, 2, 3, 4, 5, 6, 7, 8. I've got 8. So here I go. 1, 2, 3, 4, 5, 6, 7, 8. Kind of bad that I'm having to go over my picture, but well. So there's 8. Now I have the next bar. The next bar has 18s and 19s. 1, 2, 3, 4, 5, 6, 7. I've got 7 in the next bar. 1, 2, 3, 4, 5, 6, 7. And then the last bar has the 20s and the 21s, and there are 2 of those. So I have 2 in my last bar. All right. So I can see that this shape is kind of like this. All right. So I'm going to say my conclusion for those is that, and you have to write this, it is unimodal. It is somewhat symmetric. And let's see, what's the last one? Okay, and I have no outliers. So therefore now I will summarize this and end these conditions with the statement nearly normal model applies, because I'm going to have to do t-curves, so it's not a perfectly normal model. All right, so there's that. Now I'm ready to do my work. So I've done P, I've done H, I've done A. The name of the test is a one mean t-test, or you could say one sample t-test for means. So one mean t-test. All right, so now here's the other thing, is I do not have the mean and the standard deviation given to me. That means you are going to have to go to your calculator, to Stat, Edit, and go to List 1, and you're going to have to put the data in. So I'm going to put it in real quick, 12, 13, 14, and so on. So put these in there. 14, 14, how many 15s are there? There are 3 15s. And how many 16s? Let's see, there's 1, 2, 3, there's 5 16s. Okay, 17s, there's 3 17s. 18s, there's 4 of them. 19s, there are 3 of them. There's a 20, and there is a 21. Now that you have all that data in, you go to Stat over to Calc. One variable stats, and it defaults to list 1, and you hit enter, and you see that your X bar is 16.625. So the X bar is 16.625. The standard deviation of the sample is 2.22. All right, so now I'm going to go ahead and do my t-score. My t-score comes from the sample mean minus the mu over the standard deviation over the square root of n. That's the formula, which you don't have to write out, but here it goes, the numbers. 16.625 minus 15 is the mean she claims, and then the standard deviation over the square root of n, which is a sample size of 24. That is a t-value of 3.59. So to find the p-value, so to get the p-value, I'm going to go t-CDF of 3.59 up to 99, because she thinks it's the upper tail, comma, degrees of freedom, which is n minus 1. So that's 23. When you go and put that into your calculator, you get a p-value that is 0.000774. That is definitely less than alpha of 0.05. So my decision is Since the p-value is low, the null has to go. So I am going to reject the null hypothesis. And so my conclusion, which I'm running out of room, so I'm going to add it on this next page. My conclusion is, since the p-value is less than alpha, I reject that the mean hours is 15. I have evidence the average of the students is greater than, the average of the students' hours is greater than 15. And I would prefer that in place of this mu, you actually put words, but for time's sake, I'm leaving that out right now. Now let's go ahead and do the confidence interval. The confidence interval has the same P and A, has the same P and A for the panic model. So let's go straight into, or let's do the name of the test, or the name of the interval. It is a 1 mean T interval. And the formula for that is sample statistic plus or minus your critical value times your standard deviation, which we computed that sample mean is 16.625 plus or minus, let's talk about that here in a second, and then the standard deviation is that 2.22 over the square root of the sample size n. All right, now let's talk over here for a second about this critical value, which is the T star. You are told to be 95% confident. So 95% is in the middle. That puts 0.025 in one tail. So this critical value here is inverse T of one tail, comma, 23 degrees of freedom. And when you do that, you get the number 2.069. So that is the critical value that I will put in right here. When I do that computation, that gives me the interval 15.69 up to 17.56. And so my conclusion is that I am 95% confident that the average of all this professor's students' credit hours is between 15.69 hours and 17.56 hours. Okay, that's it. Now, do make sure that you are prepared to discuss if the value in number 1 is how that relates to this, meaning since this problem in number 1 was about if 15 credit hours, you know, is a reasonable claim, then you would be wanting to state something about since 15 is not in the interval, okay, this supports the average hours being greater than 15. Probably I could word that better and say since the entire interval is above 15, then this supports the average credit hours for this professor's students being greater than 15. And that's it.